And from time to time, you get a story in the media, something like this: thoughts read via brain scans. Seems to support that question I put out. Thought contents can be detected from brainwaves. And here we're saying, scientists say they've been able to monitor people's thoughts via scans of their brains. And here's where I cheat a little bit. They're not brainwaves they're reading here, okay? That was what the question said, brainwaves. These people are reading blood flow within the brain. And they're finding out which areas of the brain blood is going to. So I think that's not brainwaves. We're not reading the magnetic transmissions at a distance or radio transmissions at a distance. But what they were trying to do here was pretty coarse. And I'll show you the sorts of experiments that they were doing. So one of these studies, Hassan asked people to watch most of The Good, the Bad and the Ugly with Clint Eastwood, which must have been quite a fun experiment. And they recorded their brain activity with fMRI in various areas of the brain all the time that they were watching this film. And they had the hypothesis, which they knew from other localization studies, that certain bits of the brain were associated with detecting particular sorts of stimuli. So maybe there's a face detection area. So what they then did was they looked through the people's brain signals at the top, and this is showing blood flow in that area of the brain. And they counted all the areas where there was maximum activity in that bit of the brain. So here, that's what the numbers at the top. They're in rank order. So you can see number 1 is the most strongest peak, number 2, number 3, number 4 at the end, number 5. Then they went back to look to see what was being shown on the screen at that point in time. And here are the 5 things that correspond to the strongest 5 peaks in this part of the brain. Lo and behold, they were all close-ups of faces. So, not surprising you might think. A bit of the brain that's specialised for doing face detection shows most activity when there's a face on the screen. This is the sort of study that's taken to show we can tell what these people are thinking. Imagine we didn't know what was on the screen. We could tell from the activity in this part of the brain that they were looking at a face. So in a sense, we've read what they're thinking about from their blood flow. But they also found another bit of the brain here. The Coles bit did a similar thing. Here's the peaks, 1 and 2 in the middle, 3 right at the start, 4, 5. These were all associated with interiors of scenes and landscapes. Did you know you had a bit of the brain for detecting interior decoration and landscapes? Well, you do. And these people can look at your brains and work out if you are thinking about interior decoration and landscapes. So is that a reason to be scared? Probably not. So it's not so much that they're telling what you're thinking about, it's just they can tell what sort of stimulus you're looking at. In fact, they can also do it by thinking, what sort of stimulus are you imagining? Because the same bits of brain that are involved in perceiving stimuli are involved in building that mental representation in our imaginations. And that's where it starts to get a bit more scary. Because they can tell if you're imagining a face or imagining a landscape. And maybe we can tell if people are lying or not. Maybe we can tell if people are thinking about deception. In this experiment by Davit Zasih et al., it was quite a complicated experiment. Essentially, people were given a card, and then they were shown other cards, and they were either told to answer the question correctly or to lie about it to the computer. So they might be given 2 of hearts. They would press yes if they were supposed to be telling the truth. They would press no if it wasn't the truth. They'd get a control task just to see what their brain responses were like. Is this a 10 of spades? Yes, it is. And then they were given a signal, now I want you to lie. Do you have this card? They've got the 2 of hearts. Maybe they say yes, but they're lying. So they did this, and the computer, to begin with, knew what they were doing. So they were able to train the computer to identify the sorts of patterns over the whole brain that this person had when they were doing each of these 4 tasks. Telling the truth, doing an irrelevant task, doing a control task where the computer knew what the answer was, and lying. And after doing that, they put them through a series where the computer didn't know what they were doing. And simply by comparing their brain activity against what it had learnt about their brain activity, the computer classified their thoughts for all of these trials. The purple diamonds here indicate when that person was lying, and the red triangles indicate when that person was telling the truth. And the decision value here means that if the symbol is below 0, the computer thought you were lying. And you can see it got lies right 90% of the time. If the symbol is above 0, it thought you were telling the truth. Not so good here. It was accurate at 86%. So 14% of your truthful statements, it thought, ooh, I think you're lying. And 10% of your lies, it said, oh, okay, it let you get away with it. But still, that is probably better than I could do if you had a card and I said, are you holding up the Jack of Diamonds? And you looked at it, and it was a Jack of Diamonds, and you said no. I probably couldn't pick your lie up 90% of the time, but the computer could. So could we use these computers as a basis for lie detectors? We do this research here. Giorgio Ganis does this research in the School of Psychology. And his claim is, well, you can until the person knows what you're doing. And they're very easy to fool. Because you've just got to think to yourself, I am not lying. And you can beat this detector. Or you can say, I am lying on the control tasks and confuse it completely. So they work after a fashion, but are very easy to break. So overall, brainwaves, let's be clear, do not transmit your thoughts. They're too weak. They don't get out of your skull unless you've got a superconducting quantum interference device, and then it's not picking up the radio waves, it's picking up the magnetism. They are very weak, but we can look within your brain electrical activity to identify these P300s. They are a really useful signal in EEG recordings. We can also look at regional metabolic activity, as in the film studies. We can detect which areas of your brain are doing the processing. And if we know what that area of the brain has been associated with in other trials, we can tell what sort of stimulus you're looking at or imagining. We can tell what your intention is. If you're not trying to fool us, if you're being honest, we can tell if you're lying, if you see what I mean. So there, in a certain sense, we can tell your pattern of thinking, but that still does not count as being able to read your mind. Again, I can finish this lecture by saying, so there's no need to worry. And I hope you'll think that over all my 5 lectures. That what we've seen here in psychology is that the common myth is not always right, and things are not as sinister as you might wonder. You remember I gave you those 5 myths. This is the data. This is how many myths people believed. 40% accepted 3 out of the 5. And we've seen that one of them, I'm saying, well, maybe it is true. Big brains and IQ. We've got 59 if we accept 4, and another 3. 62% of people accepting more than half of these myths. I hope now You're all down here at the 0 or 1 or 2 area. And I hope that will stay with you. But more importantly, what I've tried to show you is that you can look at these myths and take them apart. You can reason about claims for yourself. You don't have to accept your first intuition about something. As a scientist, you can say, what's the evidence? What are the assumptions? How would I test that? And then you can go and see if anyone has tested it, or, even better, you can test it yourself. And then you can make an informed decision about these things. But often you can just do it by reasoning from first principles. Can we detect brain waves as radio waves? No. The frequency's wrong, they're too weak. You don't need to do an experiment. You can just look up signals and things on the internet. So by treating claims as statements you can think about, you can become a better thinker, and you can learn to use your brain to think for yourself. That's the message I've been hoping to get to you.